So I will go with the next question. Question is that in LSM, limit state method, the characteristics load characteristics load is defined is defined as the mean load plus plus k times the deviation, k times the deviation. Full stop. If if the characteristic load if the characteristic load is not to exceed only 5% 5% times the expected life of structure, the value of the value of k is, and your options are a 0, b 0.72, c 1.64, and d none. Now I will read the question once again. In LSM limit state method, the characteristics load is defined as the mean load plus k times the deviation. So if the characteristics is not to exceed only 5% times the expected life of structure, the value of k is 0.72, 1.64, none. So give me the answer of this question. Think on this and give me the answer. We know that the formula for standard deviation, that is Fm, is equal to FCK. This you learn in concrete technology second year, into Ks, where S is the standard deviation and this K is the constant. Okay, and this is the formula. When the condition is like this, exceeds only 5% when they told you, then in that case the value of K, that is this formula, will become, I will write the formula. In this case, this formula is Fm is equal to Fck plus 1.64s. Okay, so the value of K must be 1.64. So the answer is C. So your answer is answer C, 1.64. Okay, so your answer is answer C, 1.64. Now the next question is, in LSM, in limit state method, in LSM, the partial safety factors factors applied applied to applied to steel and concrete and concrete are. Okay, so your options are A 1.15 for concrete and 1.5 for steel. This is the first option. Second one 1.15 for both concrete and steel. C 1.5 for concrete and 1.15 for steel. D none. So what will be the answer of this question? It is a very easy question. I am expecting answer from your side. What is the answer of this? The answer is C. Okay, 1.5 for concrete and 1.15 for steel. So the answer. So the next question. The stress strain curve. The stress strain curve of the concrete of the concrete as per as per IS 456-2000 is is options are A a perfect straight line up to failure. Option B straight line straight line up to 0.002 strain value and then parabolic up to failure. Parabolic up to failure. And option C parabolic up to 0.002 strain value, then then uniform up to failure. Uniform up to failure. And last option D is linear up to 0.002 strain and uniform up to failure. Okay. These are the options given. Now they are talking about the stress strain curve of the concrete. How is the stress strain curve? We already studied this curve. Okay. Option A is a perfect straight line up to failure. Option B is straight line up to 0.02 strain value and then parabolic. Option C parabolic up to 0.002 strain value and then uniform up to failure, and linear up to 0.002 strain and uniform up to failure. These four options are given. So let me know the correct option. What do you think as a correct option? Which answer is correct? Hmm? Can anybody answer me which option is correct? Can you tell me which option is correct? Let it be your answer wrong or right, it doesn't matter, but at least you should try. Okay, so I will draw here the graph so you will understand. This is the y-axis and this is x-axis. Okay, then how the graph is there? I will draw the graph. Graph will be, so now where is stress, where is strain, that I will write first. So here on y-axis stress is there, on x-axis strain will be there. So your graph will be, it is parabolic. So this is the parabolic, and from here it is straight line. Okay, and whatever may be the value of this, if you project this value down, if you project this point here on x-axis, this your value is 0.002. This is the strain. Okay, so up to the value of 0.002, what is the shape? It is parabolic. This is parabolic. Okay, and here it is uniform. Uniform means straight. So up to the value of 0.005, the strain value, it is parabolic and then it is uniform. So your answer must be answer C. Okay. So your answer must be answer C. Next question. The characteristic strength of the concrete is, okay, option A, higher than higher than the average tube strength. Option B, lower than the average tube strength. C, same the same as average cube strength. So it is same be higher than 90% of average cube strength. A very simple question is there. So the characteristic strength of the concrete is concreteची characteristic strength काय असेल? So it is higher than the average cube strength. Cube strength, when you cast the cube and you break the cube on the CTM, you will get the cube strength. So the characteristic strength is higher than the average cube strength. Okay, lower than the average cube strength, same as the average cube strength, and higher than 90% of average cube strength. So let me know the answer of this question. Before I am going to tell you the answer, try something now. At least apply the logic. Try to tell me the answer. Whether it is wrong or right, it doesn't matter. It will improve your thinking. So let me know the answer. Anybody can give me the answer. Okay, so answer is D. Here the answer is given as D. So the correct answer of this question is, remember this, B. Okay. So the characteristic strength of the concrete is always lower than the cube strength of the average cube strength of the concrete. Okay. So the next question. Now before going to the next question, uh, we will see that what is balance section, under reinforced section, and over reinforced section. Okay, once important points I will give it to you from the point of view of this competitive examination. Some key points only. Please write down those points. Those are very important. In the class in the DCS 1, those details I have already given to you, but still take some important points. Okay, so the first is the balance section. First is balance section. So the first point in the balance section is, first point, the stresses in, this we have already seen, still take it down, it is important. Stresses in concrete and steel, stresses in concrete and steel reach to the maximum value at the same time. Okay, so it means that we said that they will fail simultaneously. So एकाच वेळेला दोन्ही fail होणार. Second point, concrete and steel, concrete and steel theoretically concrete and steel theoretically fail at same time. Okay, so on the same time both will fail. In the balance section, we are talking about balance section. Theoretically, theoretically means practically it is not possible. Theoretically, all sections, all sections design, all sections are designed, designed as balanced sections. Balanced sections. Then the failure is the failure is by primary compression. And the next important point here, it is in the balance section where XU is equal to XU max. These are some important points once we read it once. I will not go much more depth of this as you have already studied this. So the balance section, the stress in concrete and steel reach to the maximum value at the same time. Okay, so both reach to their allowable stresses or maximum stresses in the same time, concrete and steel. Concrete and steel theoretically fail at the same time. Actually, it does not happen. Either concrete fails or steel fails. So this is the ideal condition. So that is why we called it as a balance section. So concrete and steel theoretically fail at the same time. Next, third, theoretically all sections are designed as balance sections. So theoretically we can design the section as balance section, but practically it is not possible. The failure is by primary compression. Due to the compressive stresses, compression failure will be there. And XQ is equal to XQ max. This is already known to you. In the balance section, XQ is equal to what? XQ max. Okay. Next. Next is the under reinforced sections. Under reinforced sections. Okay. So the under reinforced sections, first point in this, in the under reinforced section, first point is the steel in the section is less than that required for balance section. Okay, so steel requirement is less. Second, the failure the failure is in steel. Failure is in steel causes a ductile failure causes a ductile failure and gives clear warning and gives clear warning before failure. another point. Most of the most of the practical sections are under reinforced sections. Are under reinforced sections. So here the failure is due to primary tension. Okay. The last point here, failure failure is is by primary tension. Okay. So all points already known to you under info section. Steel requirement is less, then steel will fail first. Okay. And as the steel is the ductile material, before concrete steel fails. So when the structure fails, then at that time the steel fails first than the concrete in under info section. That is why it will give, as the steel is the ductile material, it will give us the sign before the failure. It will not fail suddenly. Okay. And most of the sections, all the sections are practically designed as under imposed sections. Okay. And the failure is due to the tension, primary tension. Okay. And then this you know already. Here it is, your XU is less than XU max. Here your XU is less than XU max. Okay. And the last point we will cover, that is over info section, so that in the next lecture we will take MCQ based on this. So over reinforced sections. Okay, so in the over reinforced sections, point number one, the steel in the section is more than than that required for balance section. So requirement of steel is more in over reinforced section. Second, the failure is in concrete, so the concrete fail first. That is why we avoid these over reinforced sections. The failure is in concrete, so concrete fails causes. So concrete is not a ductile material, it is a brittle material, so it causes sudden failure. It causes sudden failure without without any warning sign. Okay, without any warning signs. So the next point is, as per limit state method, design of over reinforced sections should be avoided. Should be avoided. Okay. And the last point here, it is the failure is due to primary compression. Okay, and the last one here, your XU is greater than XU max. We will discuss, this is already known to you, just I will tell you the points. The requirement of steel is more in over reinforced sections than balanced sections. Under reinforced section मध्ये कमी स्टील लागतंय. Under reinforced sections required less steel than balanced sections, but over reinforced sections are required more steel than the balanced sections. So in the under reinforced section steel fails. Okay, steel fail होते तिथं, concrete fail होत नाही. In under reinforced section steel fails. So as the steel is ductile material, it will give just the enough warning signs before the failure. But here in over reinforced sections concrete fails. Okay, steel will not fail, concrete fails. But if the concrete fails, concrete is a brittle material, so it suddenly fails and it will not give any warning signs. Okay, as per limit state method we should avoid over reinforced sections because it suddenly fails. Okay, and here the XU is less than sorry, XU is greater than XU max. Okay, here your XU is greater than XU max. So this is the important points which I have wished to cover before moving to the next, what we can say, next MCQ questions. Okay, so in the next lecture we will take the MCQ questions based on this singly and doubly reinforced sections. Okay, so be prepared for that. We will take those MCQs.